Good morning, one and all. Now, coming to lecture 2. Now, this is evaluation of wireless communication extension. Now, in previous lecture, we have seen how 1G has evolved into 5G. That means in which year 1G has been evolved, and in which year 2G has been evolved, and in which year 3G has been evolved, and so on. Now, the existing is your 5G communication, right? Now, these all details we have seen under lecture 1. Now, after that, we have seen some basics of 2G, and we have seen its interface, air interface, that means access mode of GSM, nothing but your second generation mobile communication system. And after that, we have seen few objectives of 3G, that is third generation system. And later we have seen the radio interfaces, right, nothing but the radio links. And we have seen R1 and R3 under 3G. And later we have seen quality of services that are provided by the third generation mobile communication system. And later we have seen the traffic estimation under third generation system, right? Now, coming to lecture 2. In this lecture we will see about the standards of IMT 2000, nothing but your third generation communication system, right? IMT 2000 or third generation system, both are same. Now, here in this lecture we will see the standards of IMT 2000, and later we will see what are the technologies that are introduced in beyond 3G, nothing but we have after 3G we have 3.5G and 3.9G also. Now, what are the technologies that are included in 3.5G and 3.9G are discussed after IMT standards, and later we will see what are the modes, operating modes are under third generation system, and later we will see the specifications of 3G system, and there hence the basics of third generation system, and later we will see the requirements of IMT-Advanced, nothing but your 4G system, right? IMT 2000 is a standard given to the third generation system by International Mobile Telecommunication, and IMT-Advanced is also a standard given to the 4G systems. IMT-Advanced or the 4G system, both are same. IMT-Advanced is a standard given to the 4G system by the International Mobile Telecommunication, nothing but IMT, right? Now, these are the topics covered in this lecture. One is IMT 2000 standards, and next we will see the technologies introduced in 3G plus, nothing but 3.5G and 3.9G, and later we will see the modes of 3G, and later we will see the specifications of 3G, and after that we will see what are the requirements of the fourth generation system, right? Now, coming to next slide. Now, if you observe this figure, right, if you observe this figure, we have different technologies, right? We have WCDMA, which is of direct spread, and we have CDMA 2000, which is of multi-carrier type, and we have CDMA, which is of time division duplex, which is nothing but TDD, and we have TDMA, which is of single carrier. Now, TDMA, which is of multi-carrier. Now, these were the technologies that are made proposals by the different countries, right? If you consider WCDMA, this was proposal that is made by the Japan, right? And some China has made one proposal, and Europe has made one proposal, and Korea has also made one proposal. Now, what this International Telecommunication Union will do, it will collect all the proposals from the different countries, right? For the next generation system, it will collect all the proposals, and they will harmonize the generation, right? They will harmonize the generation. If you consider this figure, now these were the technologies: WCDMA, which is of direct spread, and CDMA 2000, which is of multi-carrier type, and CDMA TDD, nothing but time division duplex, and TDMA sub single carrier, and TDMA multi-carrier. These were the technologies that were proposed by the different countries in the year before 2000, right? In the year before 2000, because by 2000 3G has came into existence, right? Now, these were the proposals, these were the different technologies that were proposed by the different countries, like Europe made one proposal, Japan made one proposal, and China made one proposal. Now, the CDMA TDD is proposed by the China, and WCDMA DS, which is of direct spread, is proposed by Japan, and Europe has made one proposal, and Korea has made one proposal. Now, what these proposals were received by the International Telecommunication Union. Now, the ITU is responsible for harmonizing this particular technologies or the proposals that are received by the different countries, right? Not only one fixed proposal will get by the ITU, you will get different proposals, right? You will have different researchers under different countries, right? Every research has its own intention, right? Now they will collect all the proposals and they will harmonize them. That means they will coordinate, or nothing but that they will match all the proposals that are received by them, and they will generate one final system, right? Now this third generation cellular system were developed with the aim of offering high data rate and multimedia connectivity. If you see 2G system, now it provides a digital voice calls and a basic data services, right? And text messaging was also included, or nothing but they have started text messages from second generation system, right? Now the main aim of the 3G is to provide high data rate, right? Because the basic data services has started from second generation only. Now the main aim of this third generation system, or IMT 2000, is to provide a high data rate and multimedia connectivity, right? Now the ITU provides the standard. ITU is nothing but International Telecommunication Union, right? This provides the standard IMT. This has been provided the standard IMT 2000 for the third generation system. Now these standards will continue for fourth generation system and fifth generation system and sixth generation also. IMT is nothing but International Mobile Telecommunication, and ITU is nothing but International Telecommunication Union, right? ITU has given a standard to third generation system, that is nothing but IMT 2000, right? Now the main aim of this particular 3G is to provide high data rate, and another one is multimedia connectivity. Now the aim of IMT 2000, nothing but the third generation system, is to harmonize worldwide 3G system, nothing but is to match or the coordinate worldwide third generation system in order to provide global roaming, right? Now the ITU will receive different proposals from different countries. Now the ITU has given IMT 2000 as a standard to the third generation system. Now the aim of this IMT 2000 is to harmonize, nothing but is to coordinate worldwide 3G system in order to provide global roaming. If you see this figure, you will get clear idea. These were the technologies that were provided by the different countries. Now if you see this is a network, core network, right? Now one is evolved GSM. Map is nothing but mobile application part, and another one is evolved ANSI is nothing but American National Standard Institute, and next you have IP based network, right? Nothing but IP protocol. Now this is your network, core network, right? Now in order to connect one network to another network, we have a interface, right? Now this we call it as radio interfaces, right? This we call it as radio interfaces, and this we call it as network interfaces. Now network has to connect with the radio. Now the flexible connection has made between the networks and the radio interfaces, right? Now this is a medium for connecting the network and radio interfaces, right? Now these were the technologies, different technologies that were provided by that were proposed by the different countries. Now this was proposed by the Japan, and this was proposed by the China, and Korea has proposed one statement, and Europe has made its one proposal. Now what it will do, all the proposals has been collected from different countries, right? Now the ITU will give a one standard to the generation system. Now for the third generation, it has given a standard as IMT 2000. Now what is its main aim? Its main aim is to harmonize. That means in order nothing but to coordinate or to match, right? The main aim of this standard is to coordinate or to match the worldwide 3G system. That means in coordinate or to match these particular proposals in order to provide global roaming, right? In order to provide roaming across the world, right? Now this is how different proposals will receive from the different countries. Now a standard will provided by the ITU. Now the main aim of that particular standard is to coordinate or to match the worldwide systems, and in order to provide the global roaming, right? Now coming to next slide. Now here in this slide we will discuss about the technologies that are introduced in beyond third generation system, nothing but 3.5G and 3.2G. 9G, right? Now variable data rates which were supported by the means of multiple code word assignments or a variable spreading factor, right? Now coming to 3.5G and 3.9G, right? These were the advanced version of third generation system. Now this third generation system has introduced a technology which supports variable data rate, right? It supports variable data rate by providing multiple code words or the spreading factor, right? Now what I want to say is one could allocate, right? A person could allocate multiple code words to a user or a variable spreading factor, right? Now a person can allocate a multiple code words or a variable spreading factor in order to provide the variable data rates, right? Now the technology that is introduced in 3G++ is to support variable data rate by providing multiple code words and by providing multiple code words or a spreading factor. That means a person will provide a multiple code words to a user or a multiple spreading factors, variable spreading factors, in order to vary the data rate. Because see, as you vary the spreading factor, the data rate will also changes. As you vary the spreading factor, the data rate also changes. If you increase the spreading factor, the data rate will decrease, and it is inversely proportional. Spreading factor is inversely proportional to the data rate. If you increase the spreading factor, that means if you provide a user with less spreading factor, it will give you the more data rate. If you provide the user with high spreading factor, it will give you the less data rate. Data rate is inversely proportional to the spreading factor, right? Now this was the technology. What is the technology? Multiple code word assignments or the variable spread factor. This was the technologies that is introduced in the 3G++ in order to support a variable data rate. Now coming to next one, modulation and code rate were also made flexible, right? Modulation and code rate are also made flexible. That means multiple options were available so that different modulation techniques. Now in 3G++ multiple options were available so that different modulation techniques like BPSK, binary phase shift keying, and quadrature phase shift keying, nothing but QPSK, and 16 QAM, nothing but quadrature amplitude modulation, which is of 16 bits, were also brought into picture. Under 3G++, we are introducing a new technology by which we can use different modulation techniques like BPSK, QPSK, 16 QAM, right? Like this we can use different modulation techniques by providing them multiple options, right? Now this was another technology that is introduced in 3.5G and 3.9G. And next one is coverage or improvement by error correction code. Now the error correction code technology is introduced in 3G++. That means, see, we have different codes like turbo codes, we have convolutional codes, we have, right? Now the mechanism of error correction codes, nothing but the turbo codes, convolutional codes, and other techniques were brought into picture. That means error correction codes is a technology that is introduced in 3.5G and 3.9G, so that we can improve the error probability, which in turn improves the coverage, right? Now that this was another technology that is introduced in 3.5G and 3.9G, that is introducing error correction codes. If you introduce the error correction codes, it is a technology introduced in 3G++ by which you can improve the error probability, and finally the coverage of the system can be improved, right? Now coming to next one, capacity or improvement by multiple antennas as a diversity mechanism, right? Now you can improve the capacity. Because if you use multiple antennas, the capturing of it captures larger amount of energy. So if you use the concept of multiple antennas, it captures the large amount of energy, by which the signal to noise ratio becomes better, right? If you introduce a topic of multiple antennas, now that multiple antennas will capture a larger amount of energy, by which the signal to noise ratio becomes better, now which in turn improves the capacity of the system, right? Now these were the four technologies that are introduced in 3G++, right? First technology introduced is multiple code words assignments or the variable spreading factor in order to improve the variable data rate. And next we have different options were available for in order to use different modulation techniques such as BPSK, QPSK and 16 QAM. And next we have introduced a technology of error correction codes, like we have turbo codes, we have convolutional codes, we have hybrid ARQ, automatic repeat request. Now these were the technologies that were introduced in the 3.5G and 3.9G. Now this error correcting codes improves the error probability, by which you can improve the coverage of the system. And next we have next technology introduced in 3G++ is usage of multiple antennas, right? Usage of multiple antennas is a technology introduced in 3G++. Now if you use multiple antennas, the capturing of it captures larger amount of energy, right, which in turn improves the signal to noise ratio, and by which you can improve the capacity of the system, right? Now these were the technologies that are introduced in 3G++. One is assigning variable um, variable spreading factor or the multiple code words, by which you can improve the variable data rate. And next one is different modulation, different options, multiple options were available so that you can use different modulation techniques. Multiple options were available so that you can use different modulation technique. And next technology introduced in 3.5G and 3.9G is error correction codes, by which you can improve the error probability, which improves the coverage of the system. And next technology introduced in 3G++ is multiple antennas, and that multiple antennas captures larger amount of energy, by which it improves the signal to noise ratio. If you have better SNR, the capacity of the system automatically improves, right? Now these were the technologies that are introduced in 3.5G and 3.9G. Now coming to next slides, and next we will see the modes of 3G. What are the different modes that 3G operates, we will see in this slide, right? Now the following are the modes in 3G. Now the first one is it may operate in multi-carrier mode, right? It may operate not only in single carrier, also is also a proposal made by one of the country, but the actually a final conclusion is made from that proposals, and the conclusion is that it operates multi-carrier mode based on the CDMA 2000 multi-carrier option. One mode in which the 3G system operates is multi-carrier mode, and next mode in which the 3G system operates is direct spread mode, right? You know multi-carrier mode, you know direct spread mode. Again I am not saying it, just I am giving the brief description. A multi-carrier mode is one of the mode by which the third generation system operates, and the direct spread mode is the one of the mode by which the third generation system operates. And this is multi-carrier mode is based on CDMA 2000, right? Multi-carrier mode is based on CDMA 2000, and direct spread mode is based on WCDMA, which is of ULTRA FDD. ULTRA is nothing but UMTS terrestrial radio access, right? UMTS is nothing but, again you have abbreviation, you have to remember this abbreviation because it will again repeat in the future lectures also. Now ULTRA is nothing but UMTS terrestrial radio access, and UMTS is nothing but universal mobile telecommunication system, right? Universal mobile telecommunication system terrestrial radio access. ULTRA is nothing but UMTS terrestrial radio access, whereas UMTS is nothing but universal mobile telecommunication system. And FDD already you know, frequency division duplex. You have two different techniques. One is TDD and FDD in order to access the spectrum, right? FDD is nothing but frequency division duplex, in which two different frequencies are based on the two different frequencies spectrum accessing will be there. And TDD is nothing but time division duplex. In this spectrum accessing is based on the different time slots, right? Now coming to next mode of 3G, next we have TDD mode. What is TDD mode? Time division duplex, right? Now this is one of the accessing technique of accessing technique for the spectrum, right? This is one of the TDD and FDD. These are the two different methods in order to access the spectrum. If you are accessing the spectrum on two different frequencies, that will come under FDD. On different time slots, that will come under TDD. Now this TDD mode is based on UTRA. What is UTRA? UMTS, terrestrial radio access, and again UMTS is nothing but universal mobile telecommunication, right? UTRA, universal terrestrial radio access, and UMTS is nothing but universal mobile telecommunication time division duplex, right? Now if you see the UTRA, FDD and TDD, now the chip rate were changed from, for FDD you have maximum chip rate and for TDD you have less chip rate. If you compare the chip rate of FDD and TDD, FDD will have maximum chip rate and TDD will have less chip rate, somewhat less, a slight variation only, right? Now these were the modes in which the 3G operates. One is multi-carrier mode and another one is direct spread mode and another one is time division duplex mode, right? Now coming to next slide, we have specifications of 3G, right? Next slide is specifications of 3G. Now the first specification of 3G is channel bandwidth. Now the 3G has a channel bandwidth of 5 megahertz, right? 3G has a channel bandwidth of 5 megahertz. If you observe the first one, now the channel bandwidth that is provided by the third generation system is 5 megahertz. Now it supports FDD and TDD, frequency division duplex and time division duplex. Now the spread spectrum technique that is supported by the 3G, we have seen three different modes, right? One is multi carrier mode we have seen, and next one is we have TDD, and we have seen TDD mode on UTRA TDD, and next we have seen direct spread, right? Now this maximum it will support direct spread only. The spread spectrum technique that is supported by the 3G is direct spread. Now the chip rate it has is 3.84 megahertz. Now the chip rate of third generation system is 3.84 megahertz. Now what is mean by chip rate? It is nothing but, chip is nothing but the pulse you will have. Then the chip rate is nothing but the number of pulses per second at which the code is transmitted or received, right? Chip rate is nothing but the number of pulses per second. Per every second, how many number of pulses at which the code can be transmitted or received, right? Chip rate is nothing but the number of pulses per every single second at which a code can be transmitted or received. That the chip rate is nothing but 3.84 megahertz. That means it has a maximum chip rate. For 3G provides a maximum chip rate. Chip rate is nothing but a number of pulses per second. How many pulses per second are there in order to transmit or receive a code, right? And next we have frame length. Now frame length is nothing but it is 10 milliseconds. Frame length of 3G is nothing but 10 milliseconds. That means, see, if you consider a channel, what is frame length, what is slot length, I will say now. Now if you consider a channel, now channel is divided into 10 millisecond frames. 10 millisecond frames, and each of which has 15 time slots, right? Each of which has, see, now if you can, now this is your channel. Let us assume you have a channel. Now the channel is divided into 10 millisecond frames, right? 10 millisecond frames, and each of which has 15 slots per frame. That means for every frame you have 15 slots, right? Now the a channel under 3G is divided into 10 ms frames, right? 10 millisecond frames, and each of which has 15 time slots, and each slot has 666 ms length, right? You have to remember, frame length is nothing but the channel is divided into number of frames, right? A particular channel is divided into number of frames that is given by 10 ms, and the slot length for, see, now the channel is divided into 10 ms frames. Now the each frame has 15 slots, right? Each frame has 15 slots, nothing but 15 slots per frame. And the modulation technique that can be used under 3G is QPSK for downlink and BPSK for uplink. QPSK is nothing but quadrature phase shift keying for downlink, and BPSK is nothing but binary phase shift keying for uplink. Now the channel coding. Either you can use convolutional code for the error probability or turbo code, right? These are your error correction codes, and sometimes you may not require coding also, right? They may use error correction codes or they may not use error correction codes, right? Now coming to next specification, that is spreading factor. Spreading factor, it is nothing but the ratio of chip rate to the data rate, right? Actual data rate. Spreading factor is nothing but the ratio of chip rate to actual data rate, right? As I have said in the earlier slide, spreading factor is inversely proportional to data rate. This is how the relation between spreading factor and data rate. Spreading factor is nothing but ratio of chip rate to actual data rate, right? Now the spreading factor is 4 to 256 for uplink. It may vary in between 4 to 256 for uplink transmission and 4 to 512 for downlink transmission. As you increase the spreading factor, the data rate will decrease, but that's why LS spreading factor is preferred for your 3G system. Spreading factor, it is nothing but the ratio of chip rate to actual data rate, right? Now the spreading factor is inversely proportional to data rate. As you increase the spreading factor, the data rate decreases. As you decrease the spreading factor, the data rate increases, right? That's why less spreading factor is preferable, right? And next we have modulation symbol rates, right? Next we have modulation symbol rate, nothing but the number of symbols changes across the transmission medium per unit time, right? Modulation symbol rate is nothing but change in the symbols. Symbol rate is nothing but the change in the symbols across the transmission medium per unit of time. That's why you'll have 960 kilo symbols per second and 7.5 kilo symbols per second. If you observe the units, you will have symbols per second. Symbol rate is nothing but the change in the symbol across the transmission medium per unit time, right? Now this may vary from 960 kilo symbols per second to 15 kilo symbols per second for uplink, and to 960 kilo symbols per second variation to 7.5 kilo symbols per second for downlink, right? Now these were the specifications of 3G. Now again I am repeating. Now the 3G has a bandwidth of 5 megahertz. The channel bandwidth for 3G is 5 megahertz, right? Now the duplex mode, it is supported by the 3G is frequency division duplex and time division duplex. These were the techniques that are used to access the spectrum. If you are accessing the spectrum for different frequencies, it is nothing but FDD. If you are accessing the spectrum by different time slots, it is nothing but TDD. It supports both FDD and TDD. Now the spread spectrum technique that is supported by the 3G is direct spread. We have in previous slide we have seen the different modes of 3G. One among them is accepted by the 3G, that is direct spread. And next it has a chip rate of 3.84 megahertz. 3G has a chip rate of 3.84 megahertz. Chip rate is nothing but the number of pulses per second at which the code can be transmitted or received, right? Chip is nothing but the pulse rate, we call it as the number of pulses per second at which the code can be transmitted or received, right? Chip rate is nothing but the number of pulses per second at which the code can be transmitted or received. And the chip rate for 3G is 3.84 megahertz. If we consider chip rate for 4G, it will again be higher. It will be higher. And next we have frame length. The channel is divided into number of frames. That number of frames is 10 ms, right? Now the channel is divided into number of frames. Now that number of frames, right, is nothing but the 10 milliseconds. The frame length is 10 milliseconds, and the slot length, each frame will contain 15 slots. So if you consider, it is these two are interrelated to each other, frame length and slot length. Now first the channel is divided into n number of frames. Now each frame will contain, internally it contains slots, right? Now the frame length is 10 ms. The channel is divided into number of frames and the frame length is 10 ms, and each frame will contain 15 slot, nothing but the slot length. Now the modulation that is supported by 3G is QPSK and BPSK. And next, error correction codes that are supported by the 3G, that are used by the 3G are convolutional code, turbo code, and sometimes they may not use that, the 3G systems may not use error correction codes, right? Now coming to spreading factor. What is spreading factor? It is the ratio of chip rate to actual data rate, right? Spreading factor is the ratio of chip rate to actual data rate. If you observe the definition, spreading factor is inversely proportional to data rate, right? Now spreading factor, it is the ratio of chip rate to actual data rate. Now if you see the definition, it is inversely proportional. Data rate and spreading factors are inversely proportional. Now spreading factor will vary from 4 to 256 for uplink transmission and 4 to 512 for downlink transmission under 3G, right? Now the lower spreading factor is preferred because why it is preferred? Because we require high data rate, because since spreading factor is inversely proportional to data rate, the less spreading factor is preferred in order to acquire more data rate, right? Now the coming to next specification, modulation symbol rate. Symbol rate is nothing but change in the symbols across the transmission medium per unit time, right? Per unit time. Now the modulation symbol rates vary from 960 kilo symbols per second to 15 kilo symbols for uplink and 960 kilo symbols per second to 7.5k symbols per second for downlink, right? 960k to 15k for uplink and 7.5k to 960k to 7.5k for downlink, right? What is symbol rate? Change in the symbol across the transmission medium per unit time, right? Across the transmission medium per unit time. These were the symbol rates that are supported by the 3G for uplink and downlink, right? Symbol rate is nothing but change in the symbols across the transmission medium, change in the symbols across the transmission medium per unit of time, right? Now under 3G for uplink, it will change from 960k symbols per second to 15k symbols per second, and for downlink it will change from 960 kilo symbols per second to 7.5k symbols per second. Now these were the specifications of 3G, right? Now coming to next slide, we have comparison between WCDMA and GSM, right? Comparison between WCDMA and GSM, right? Now GSM is nothing but your second generation system and WCDMA is the access method for your third generation system, right? Now coming to carrier spacing. Now the carrier spacing for WCDMA is nothing but the bandwidth, channel bandwidth for your WCDMA is 5 megahertz and for GSM we have 200 kilohertz, right? Now the carrier spacing or the channel bandwidth for WCDMA is 5 megahertz and for GSM it is 200 kilohertz. And next we have frequency reuse factor, right? You know already what is meant by frequency reuse. The rate at which frequency can be reused in the cell, right? Now the frequency reuse factor is 1 for WCDMA, right? Frequency reuse factor is 1 for WCDMA, and for GSM you have 1 to 18. Frequency reuse factor is 1 to 18, right? And next you have power control frequency, right? Power control frequency. Now what is meant by power control? It is used to minimize interference. This power control is used to minimize interference due to fading or the presence of other mobile users in the particular cell, right? Now the power control the frequency at which, right, the frequency at which you can minimize the interference, right? The frequency at which you can minimize the interference due to fading or the presence of other mobile users, right? It may be some reasons, it may be for some reasons, but you are getting interference in the cell. In order to avoid that, we will use this term power control frequency, and that is for WCDMA we have 1500 hertz and for GSM we have 2 hertz or lower. You see, if you observe this term, power control frequency is less for your GSM. That means you cannot minimize the interference. You cannot minimize
may or may not, but it is less, right? You cannot minimize interference under GSM as you compare to minimization of interference under WCDMA. Power control is nothing but it is a technique used to minimize the interference in a cell, right? And that technique is required at a frequency of 1500 Hz for WCDMA, and GSM it has 2 Hz or lower. And coming to next term, quality control. Quality control under WCDMA, it is done by the radio resource management algorithms, and under GSM quality control is done by the network planning or the frequency planning. Now coming to next term, we have frequency diversity, right? Frequency diversity, now this gives the multipath diversity with rake receiver under WCDMA and for frequency hopping under GSM. Now coming to packet data, now WCDMA load based packet scheduling. Now GSM it uses time slot based scheduling with GPRS, right? Now coming to next term, downlink transmit diversity. Now this is supported by the WCDMA for improving the downlink capacity. Now this is not supported by the GSM, but it can be applied. Though it is not supported by the GSM, it can be applied. Now this is the comparison between the WCDMA and GSM. Now the channel bandwidth for WCDMA is 5 MHz, for GSM is 200 kHz, and the frequency reuse factor, nothing but the rate at which frequency can be reused in a particular cell. Now that is 1 for WCDMA, and for GSM it is 1 to 18, right? Now the power control, it is used to minimize, power control is used to minimize the interference in the cell, and it is used to minimize the interference in the cell at a frequency of 1500 Hz under WCDMA and 2 Hz or lower under GSM. Now coming to the quality control is maintained under WCDMA by radio resource management algorithm, and quality control is maintained under GSM by network planning or frequency planning, right? Now coming to next one, frequency diversity. Now the 5 MHz bandwidth gives multipath diversity with rake receiver. Rake receiver is introduced in the third generation systems only, right? Now the 5 MHz, nothing but the channel bandwidth gives the multipath diversity with rake receiver, but GSM supports frequency hopping, right? Now coming to packet data, now this will load the packet scheduling, load based packet scheduling, and this will time slot based scheduling, right? It supports time slot based scheduling and load based packet scheduling. Now coming to next term, downlink transmit diversity. Now this is supported by the WCDMA in order to improve the downlink capacity. Now GSM doesn't support downlink transmit diversity, but it can be applied. It can be applied in a different manner, right? Now coming to next slide. Now there ends the 3G basics. Now from here we will see the beyond 3G, right? Beyond 3G, 3.5G and 3.9G. Now if you see this figure, capabilities of IMT 2000 and systems beyond IMT 2000. IMT 2000 is nothing but the standard that is given to the third generation system by International Telecommunication Union, that is ITU, right? Now here what are the capabilities of IMT 2000 and the systems beyond IMT 2000 we will see in this slide, right? On x axis, if you observe, on x axis we have data rate megabits per second, data rate whose units are megabits per second. On y axis we have mobility, right? On x axis you have data rate, on y axis you have mobility, right? Now if you see this figure, here we have IMT 2000. IMT 2000, that is nothing but the third generation system, right? Now the IMT 2000 is designed to support, now earlier 2G, after 2G we have 3G. Now 3G is designed to support high mobility situations, whereas data rate is not really that high. If you see this, see till here we have, see if you see this till orange color we have IMT 2000. Now this IMT 2000 supports high mobility, right? This IMT 2000 supports high mobility, but it has less data rate. From this figure you can conclude the statement, right? IMT 2000, which is a third generation system, now this supports high mobility but it has less data rate, only a few megabits per second, around 6 to 7 or 8, right? It varies from 6, 7 or 8 megabits per second data rate, right? Which is not a really high data rate, right? Because if you observe on x-axis, you have 1000 mbps also, megabits per second data rate also, but the data rate of IMT 2000 is not that high, right? Is not that high. And if you see, this enhancement has been done, that means we are uh, going to the next generation system. We are going to the advanced version of IMT 2000, IMT 2000 to IMT enhanced IMT 2000, nothing but advanced version of 2000. Now if you see this light orange color, again you have light yellow or light orange shade. Now this supports high mobility, right? The mobility remains constant, but the data rate has been improved, right? If you see this figure, if IMT for IMT 2000 mobility is high, but the data rate is only of few megabits per second, which is not preferable, because why means we require high data rate, we require high mobility and also high data rate, but 3G supports only high mobility but it doesn't support high data rate. That's why we are going to the advanced version of 3G, that is enhanced 3G. Now if you observe this figure, right, now this is again slight or light orange color shaded. Now the mobility is maintained constant, right? The mobility is maintained constant, but the data rate has been increased, right? It will be around 50, 60 or 70, greater than 50 to 100. It will be in the between 50 to 100 megabits per second, right? Toward now the development has been started from 3G to enhanced version, nothing but the 4G, in order to improve the data rate. The mobility is remained constant and the data rate has been improved, nothing but your 4G system, right? Now if you see this figure, now the system beyond IMT 2000, nothing but your 4G system, will encompass the capabilities of previous system, right? Now here as you go from, now this is your third generation system and this is your fourth generation system, and here you will have fifth generation system, and again the mobility is maintained constant and again the data rate is improved, and beyond the fifth generation system again we have sixth generation system, again the mobility it remains constant and the data rate will be improved. That means as you move from one generation system to other generation system, the mobility is maintained constant from third generation to fourth generation and fourth to fifth, fifth to sixth, and the data rate has been keeps on increasing. This is what the picture wants to conclude, right? Now the mobility will remain constant whether it may be 3G or 4G. The data rate has been decreased, right? The data rate has been increased from few megabits per second to higher megabits per second. Now the dashed line is nothing but this thing. Now the exact data rates associated with system, this dashed line indicates the exact data rate. Now this is your 4G and this is your 3G, and these are the advanced versions of 4G beyond 4G system, right? Now what I want to say is, third generation system is providing a high mobility with lesser data rate, and now in order to improve the data rate we have to go for the advanced version, that is your enhanced IMT 2000, nothing but 3G, enhanced 3G, nothing but your fourth generation system. Now this fourth generation system, under fourth generation system the mobility is maintained constant and the data rate has been improved. Now if you go beyond your fourth generation system, again enhancement of IMT Advanced is nothing but fourth generation system, again the mobility is maintained constant and the data rate has been improved. Now this dashed line, this indicates the exact data rates. Now this dashed line indicates the exact data rates that are associated with the systems beyond IMT 2000. What are the systems beyond IMT 2000? 4G, 5G, 6G and so on, right? Now here you have to remember 3G supports high mobility with less data rate. Now in order to improve the data rate we are going for 4G systems. Now there we have improved the data rate, again we want more data rate, again we have to go for fifth generation system. It doesn't stop, it will go on, keeps on continuing. Now again we want more data rate. Now 5G advanced version is nothing but your this keeps on increasing, right? Now coming to next slide, requirements of IMT Advanced, nothing but your fourth generation system, right? What is IMT? International Mobile Telecommunication, right? In IMT is nothing but International Mobile Telecommunication Advanced System, nothing but your fourth generation system. Now in this slide we will see what are the requirements of 4G systems, nothing but IMT Advanced. This is the standard given by the International Telecommunication Union, right? ITU, International Telecommunication Union, given the standard for 4G system, that is IMT Advanced. What is IMT? International Mobile Telecommunications, right? Now this IMT Advanced systems includes a new capabilities of IMT that go beyond those of IMT 2000. Generally it includes, what are the new capabilities? We have the we want to have larger data rate. Now what are the new capabilities? We will see in this slide, right? Now the IMT Advanced system supports high mobility application, as I have said in the previous slide. Now this is your enhanced IMT, nothing but your 4G. It supports high mobility application, that is the one of the requirement of 4G. Low to high mobility application and wide range of data rates, right? If you see this slide, now a few Mbps to high Mbps, wide range of data rate, that is one more requirement of IMT Advanced. Next, high quality multimedia applications, right? This is one more the requirement of 4G system. And next we have worldwide roaming. Worldwide roaming is one more requirement of IMT Advanced. Now next requirement is peak data rates, that is 100 megabits per second for high mobility and 1 gigabits per second for low mobility, right? These were the peak data rate requirements for 4G system, right? Now these are the requirements of IMT Advanced. One is low to high mobility application, that means it should have high mobility. Next it should have high data rate, and next it should have high quality multimedia application, and it should provide worldwide roaming, and it should have data rate of 100 megabits per second for high mobility and 1 gigabits per second for low mobility, right? Now these are the requirements of IMT Advanced, right? Now in the next lecture, before going in detail into fourth generation system, we will see some terminology like spectral efficiency, peak power efficiency, cell bandwidth, enhanced cell bandwidth. We will see some terminology before going in depth into the fourth generation system, right? Now till now we have seen basics of 2G, basics of 3G, and harmonization of 3G. And next we have seen 3G modes, technology introduced in 3.5G and 3.9G, some specifications of 3G, and next we have seen difference between 2G and 3G, and next we have seen what are the capabilities of IMT and beyond IMT, right? And next we have seen requirements of IMT Advanced. What are the requirements of IMT Advanced? High mobility, high data rate, right? Now high quality and worldwide roaming, and next we have peak data rates. It should provide less data rate for high mobility and high data rate for less mobility, right? Now here ends your lecture 2. In the next lecture we will see some terminology like cell spectral efficiency, peak power efficiency, cell bandwidth, like etc. Like this we will see some terminology in the next lecture, right? Thank you.